Welcome to the Unit 1, Section 2 video on solutions of equations. We've talked about solving equations. Now we're going to talk about justifying steps for solving equations. Each step that we have taken, there has been a specific reason for that step. Properties of equality allow an operation to be carried out on each side of the equation while keeping the equation balanced. So we have talked about doing these things, and we have done these things, but now we're going to formally call them by what they are. The addition property of equality, if we have A equals B, we can add C to both sides and it remains equal. Similarly, the subtraction property of equality says that if we take two sides that are equal, we can subtract the same thing from each side and they remain equal. In multiplication, same deal. If we have two sides that are equal, we can multiply each side by the same thing and it remains equal. In division, we can divide each side of an equal set of variables and we still have something that's equal on each side. The only thing about division is C cannot be 0 because you cannot divide by 0. That's undefined in mathematics. So notice in all four of those, whatever you do to one side, you have to do to the other to keep them equal. This is something that we've already talked about. Recall for multi-step equations, the distributive property and combining like terms may also be necessary. So here's a reminder of the distributive property. There should be sound mathematical reason for every step in solving an equation. The above properties can be used to justify each step. So to justify steps for solving an equation, you're going to begin with the given equation. You're going to determine what property was used to achieve the next step, and then you'll repeat the process until reaching the solution for the equation. And these are the properties that you have to choose from for each step in solving an equation. The distributive property, combining like terms, and then your four properties of equality for addition, subtraction, multiplication, and division. So in example 1, we're going to justify each step. So our first statement is our given equation. Now, what is the first thing we're going to do? Well, if you remember, don't call me after midnight tells us to distribute first. So we're going to distribute that 5 to the x plus 2. And that gives us 5x plus 10 on the left-hand side. So the reason for that step is the distributive property. That's what got us from the previous step to this step. Now our next statement is going to be moving the variable. And to move the variable, we're going to subtract 3x from each side, giving us 2x plus 10 on the left. And since we subtracted 3x from each side, we used the subtraction property of equality. Now we're going to subtract 10 from each side. And when we subtract 10 from each side, again, that is going to be the subtraction property of equality. And then finally, we divide each side by 2. And that is the division property of equality. In example 2, again, we are started off with our given. We are going to multiply 3 out to the x minus 2. So when we did that, we used the distributive property. Next, we're going to combine the 3x and the 5x on the left-hand side. So 3x plus 5x gives us 8x, and here we combined like terms. Now we're going to move the variable by subtracting 9x from each side. So that gives us negative x minus 6 equals negative 24. And since we subtracted 9x from each side, that was the subtraction property of equality. Next, we're going to add 6 to each side to give us negative x equals negative 18. So that is the addition property of equality. And then finally, to get rid of the negative, you either have to multiply or divide each side by negative 1. So here I just called it the multiplication property of equality because I multiplied each side by negative 1. This could have also been stated as the division property of equality because you can divide each side by negative 1 and get their same result. In example 3, we're going to start off with our given. We're going to distribute the negative 7 out to what's in parentheses. So we use the distributive property. Next, we've got to move the variable. So we add 56a to each side. So that was the addition property of equality. Now we're going to add 3 to each side. Again, that's the addition property of equality. And then finally divide each side by 52, and that gives us 1 equals a, and that is the division property of equality. Now that we've talked about solving equations, we want to take shortcuts and not write down every step, or at least that's going to be your temptation. You can add, subtract, multiply, and divide in your head without necessarily writing down the operation explicitly. However, once you stop writing down each step, it is easy to make mathematical mistakes. If you always check your solution by using substitution, you will know if you've made a mistake. In other words, take your solution and substitute it in for the variable to see if you get a true statement. If you get a false statement, then you need to double check the steps and make corrections. And this is why it's so important to write each step of your work so you can go back and find your mistake without having to start the problem completely over from the beginning. So let's watch out for the following common mistakes. The first is adding the opposite to one side, but adding the original to the other side. So in this particular example here, we are given 2x minus 10 equals 2. To get rid of that minus 10, we need to add 10 to each side. Well, the mistake that was made here is that we added 10 to the left side, but we subtracted 10 to the right side, and that gave us the incorrect solution. For number 2, multiplying by the reciprocal on one side, but multiplying by the original factor on the other. So in this example here, first we added 2 to each side, so that's good. 7 plus 2 is 9. That leaves us with 3r. But here, we should multiply each side by 1/3, but instead we multiplied the right side by 3 and not 1/3. So that is where our mistake is in this one. For number 3, making arithmetic errors, especially with negative numbers. When adding, subtracting, multiplying, or dividing with negative numbers, it is easy to make a mistake. Double check your math. So we're given negative 2b plus 7 is equal to negative 14. Well, if we subtract 7 from each side, that gets us to step 1, so that checks out. But going to step 2, we divided the left side by negative 3, but we divided the right side by positive 3. Okay? So in this case, the negative was forgotten. Simplifying terms that cannot be simplified, you want to make sure that you add only terms that are alike. Terms that are not alike cannot be combined or simplified. So in the given here, we have 4a minus 2ab equals 6 plus 4. Our mistake is in step 1 because 6 cannot be added. 6 plus 4 can be combined correctly to get 10, but on the left-hand side, 4a and negative 2ab cannot be combined because they are not like terms. Another common mistake is multiplying only the first term inside the parentheses by the factor outside the parentheses. This happens when you distribute, okay? So take a look here at step 1. 4 times c is 4c. 4 times negative 6 should give you negative 24, not negative 6. Here we forgot to multiply the 4 by the negative 6. So in this example, we're going to identify the mistake in the problem. So a way to go about this is to check our work step by step. So first thing we have to do is distribute. 3 times 3y gives us 9y. 3 times negative 1 gives us negative 3. So step 1 looks good. In step 2, we are going to move the variable. To do this, we are going to subtract 9y from each side. When we subtract 9y from 3y, that should give us negative 6y, not positive 6y. So there's our mistake. It's in step 2. We should have added 3y plus negative 9y to get negative 6y, instead of making an arithmetic error and getting 6y. For example 5, we're going to identify the mistake here. So let's start with step 1. We start by subtracting 4a from each side to move the variable. 3a minus 4a does give us negative a. So step 1 looks good. Next, we're going to subtract 5 from each side. So we do that. We get negative 2 minus 5 gives us negative 7. So step 2 looks good. And then we're going to divide each side by negative 1 or multiply each side by negative 1. And that's where our error is. Step 3, we should have divided by a negative to get positive 7 instead of making the arithmetic error and getting negative 7. So far, all the equations we've solved have had some solution for the variable. But what happens if the variables go away? Well, that gives us what's called special solution sets. And to understand special solution sets, we need to first talk about identities. An identity is an equation that is always true, no matter what value is substituted for the variable. The solutions of an identity are all real numbers. Some equations are always false. These equations have no solutions. So for solution sets, the ones that we've done so far have had one solution. You get some number equal to that variable. In this case, the variables do not cancel, and your answer is a number. You have no solution when the variables cancel out. If the variables cancel out, you're going to get some number equals some number. And if that two numbers are not the same, then you have a false statement and you have no solution. But if the variables cancel out and the two numbers are equal to each other, then you have a true statement and you have infinite solutions. So let's take a look at an example of no solution and infinite solution, starting with A. We're going to solve this as we've always done, first by combining our like terms on the left and the right side. So that gives us 4 minus 5x equals 4 minus 5x. Well, you can already tell that we have a true statement, but let's go ahead and cancel out the variables by adding 5x to each side, and that leaves us with 4 equals 4. This is a true statement, so therefore we have infinite solutions. In B, we're going to combine our like terms on the left-hand side. So we get x plus 6 equals negative 17 plus x. Subtract x from each side, and that leaves us with 6 is equal to negative 17, which is not true. They are not equal, so therefore we have a false statement and no solution. Now let's talk about verifying solutions. Once a solution is found for an equation, you can easily verify the solution by substituting the value for the variable back into the original equation. We've already talked about this a little bit. It's a way that you can check your work. If the result is a true statement, the value is verified and your solution is correct. If it is false, the value is not a solution and the work should be reviewed for errors. So for example 7 here, let's verify the solution for each problem. If it is not a solution, we're going to solve the equation. So for A, we have solved this equation and we found that m equals 4. Now we want to check to see if that solution is correct. So we're going to substitute 4 in for m, and then we're going to use our order of operations on the left-hand side to see if it equals 13. So 3 times 4 gives us 12, and then 12 plus 4 gives us 16. So that is not equal, so the solution that we came up with is not a solution. So let's solve it. 3m plus 4 equals 13. We're going to subtract 4 from each side. That gives us 3m equals 9. And then we're going to divide each side by 3, and that gives us m equals 3. So the correct solution to this problem is m equals 3. For B, we have found the solution to be n equals 2. Let's see if that is correct. So we're going to substitute 2 in everywhere there's an n. So 8 times 2 on the left-hand side gives us 16. 2 times 2 on the right-hand side gives us 4. 16 minus 7 on the left gives us 9. 4 plus 5 on the right gives us 9 as well. So since 9 equals 9, our solution is verified. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.